Let's solve 1 over x squared plus 2x is equal to 0. Well, the first thing we need to do here is combine these together, so they're going to need common denominators. I have 1 over x squared, and I'll have to rewrite 2x with the denominator of x squared, so the numerator multiplied by x squared is 2x cubed. And then all that equals 0. So now that they have common denominators, I can rewrite this as one rational expression, 1 plus 2x cubed, all over x squared equals 0. And from here, in order for a quotient to equal 0, I set the numerator equal to 0. So 1 plus 2x cubed equals 0. I'll subtract the 1 and divide by 2. I get x cubed is equal to negative 1/2. And then I need to take the cube root of both sides. I get x is equal to the cube root of negative 1/2. And it is possible to have a cube root of a negative number. Now let's solve x to the negative 2 minus x to the negative 3 is greater than 0. First, we'll go ahead and factor. Between these two terms, I can factor out an x to the smaller exponent, which would be x to the negative 3. Then I'd have x to the negative 2 minus negative 3 minus 1 is greater than 0. So that's x to the negative 3 times x to the first power. So negative 2 minus minus 3, that's negative 2 plus 3. That's just x to the first. Minus 1 is greater than 0. So what we have is an x minus 1 in the numerator, and we'll drop x to the negative 3 to the denominator, make it x to the positive 3. So when is that greater than 0? Well, now we can really see this is a rational expression on the left. And to solve it, I want to create a number line. I want to do a sign analysis. So I'm going to set the numerator equal to 0 to find the zeros. X plus 1 equals 0. I get x equals 1. That's a 0 of my function. And then if I set the denominator equal to 0 to find where I'm undefined, I get x equals 0 is where I'm undefined. So now we'll go ahead and construct our number line from negative infinity to infinity. We'll mark 1 as a 0, and we'll mark 0 as a place where I'm undefined. So I'll make that like a vertical asymptote. And then we'll pick some test values. So negative 1 is between negative infinity and 0. Between 0 and 1, let's pick a half or 0.5. And between 1 and infinity, let's pick 2. And we'll substitute that into the factored version, x minus 1 all over x cubed. And so negative 1 minus 1, that's a negative in the numerator. A negative cubed is going to give me a negative. So a negative over a negative is a positive. If I plug in 0.5 minus 1 is negative. And 0.5 cubed is some positive number. So a negative over a positive is a negative. And if I plug in 2 minus 1 is positive, and 2 cubed is positive. So this final interval here is positive. We did want greater than 0 or positive intervals, so I don't want this middle interval. So my answer in interval notation will be from negative infinity to 0, open parentheses around 0, because that's where I'm undefined, and from 1 to infinity, also open parentheses around 1, that's where my function is equal to 0. I want to know where I'm greater than 0. So these are the two intervals where this rational expression is greater than